So our next speaker is someone who has more than 18 years of experience in IT. He is a Google developer expert and a solution architect at Palo Alto Networks. With that, with a huge round of applause, can I please invite Mr. Dharmesh Vaya on the stage, please?
Okay. Good morning, Gandhinagar. Kem cho? Still not that good. Not Majama. You all don't seem to be in Majama. Hello, everyone. Good morning. Good morning. Still a bit sleepy? A little bit? No? Okay. Chalo, let's ensure that you are not sleepy further for the next at least 40 minutes. Right? So yes, thanks again, team, for inviting me. This is Dharmesh Vaya. I work as a solutions architect at Palo Alto Networks, working with a product called Prisma Cloud, which is basically whatever Rinkesh sir told, how do you protect everything out of it? That's where my product does that job, right? So that's what I do as a day job. Right, and I happen to be a GD for cloud payments category, running a similar chapter in Mumbai, like how the cloud team in Gandhinagar does that. We run similar shows in Mumbai as well, right? So with that, let's get started. Probably a bit more about me if you want to know. Whatever I said in the last few minutes, that's all captured in this slide as well. You can refer to my blog, which is called CloudZone, with a K, since I also happen to work a lot with Kubernetes as well. Right, with that, let's get started. Right, so, okay, so to set some context, right, now, if you anyone over here, I mean, a lot of you probably are already developing AI apps. How many of you all? Show of hands. Yeah, quite a good bunch of folks who are doing AI apps, right? Where do you run those AI apps? Where do you run? Yeah? To be in private clusters, yeah? Okay. On your VMware stack, correct? That is one way to do that, because you are sensitive to your data, to your models, and you want to kind of have your models and your training sets running on-prem clusters, right? What about, how do you serve those models, or how do you provide an end user experience with reference to these models? Where do you run that? Probably on cloud, some of y'all, correct? Okay, what do you need to run AI? What do you need to run AI? Anyone? Yeah? Sorry? Okay, computation power should be high. Okay, that is one. Okay, so jokes apart, right? Computation power is definitely the technical aspect of it. To run AI, you need human intelligence, first of all. Okay, so that's one part of it, right? It's not everything artificial. You will need a lot of human computational power to run any sort of AI, right? But yes, as someone rightly pointed out, you need a lot of computational power, right? But if you talk of, where you want to serve these layers, where you want to run this infrastructure, probably you don't know that how much of infrastructure might be required. Now, if you take a look at this slide, right, what does cloud provide you, right? You get a lot of scale. I mean, I think we all have come off an age where you don't need to explain what is cloud, right? It gives you scale. It gives you automatic VM provisioning. It automatically helps you cluster management and all that, right? Taking you a bit further into, how cloud systems operate, right? Probably, there could be automated VM mechanisms. There could be managed Kubernetes, wherever you are running, whether it's AI or any of these models, correct? But let's say you don't want to get into all this hassle. You say that, okay, I am an app developer. मेरे को इससे कुछ लेना देना नहीं है. तुम कैसे चलाओ, VM चलाओ, Kubernetes चलाओ. I don't know how to run it, right? You want to ensure, okay, कि मेरा app, whether it is 10 users, whether it is 1,000 users, whether it is 10,000 users, right? चलना चाहिए, ठीक है? There should be no crash. There should be no 404s. There should be no 503s, right? That should not be the case, correct? So with that, right, cloud providers thought कि यार applications guys, why should we kind even let them bother about the infrastructure? There could be roles which are infra specific. They will manage all this, right? But if an application guy thinks that, I don't want to worry about scale, then what do you get? Serverless, right? Anyone using serverless, services on cloud? Yeah, a few of them. Any examples?
Cloud stuff.
Cloud Run. Yeah, you all saw the topic and came. Okay, good. Okay, you all are genuinely using Cloud Run. That's good, right? And it's a very beautiful service, right? Probably one of the most, I would say, scalable, stable service that you can think of, right? And that will kind of help you to focus on your application objectives or your business objectives, right? And you might not have to worry about scale or even performance as such, right? So that is where serverless systems or functions become more powerful. Let's take a step back, right? Probably someone was using VMware, right? Generally, what you do with these kind of traditional systems is that you over provision, correct? You know that you might have 1,000 users using it, right? But you will provision ki yaar 1,000 ke jagah pe 1,500 aa gaya. Let me plan it for 1,500 or let me plan it for 2,000, right? You know that you will have to over provision, correct? Which means that it's an added overhead cost for you, correct? आपको 8 GB का CPU लगेगा, ठीक है, और 8 vCPU लगेगा, but you are provisioning it as 16 vCPUs, right? You are over provisioning, which means an added cost, right? So to optimize this, right, serverless will kind of handle this for you, right? In fact, we'll see probably one live demo, and that can help you understand that when someone is not serving anything, right, there are actually 0 instances of it running, right? Which means that, let's say, I hit a HTTP request on a URL, right? Only at that time, right, my container will spin up and then start serving, right? That's exactly the beauty of serverless and the power of computing that is going to help you. So whenever you see that, probably there is a spike, it means that a lot of requests are coming in, okay? So again, the underlying factor over here and the most crucial one, focus on your application, not the infra. And that is what, even when you talk of AI systems or any kind of payload that you are trying to develop, right? What do you have to focus on? Your AI model, your training data sets, and the whole model that you are creating, correct? So without worrying about the infrastructure, you can kind of proceed forward, right? So then how do you choose, right? Yeah, there are so many systems. If someone says कि Kubernetes use करो, कोई बोलेगा कि ठीक है VMs पे चला लो. Someone will say okay मैं on-prem चलाता हूँ. ठीक है, how will you actually decide, right? So especially if it is on the GCP ecosystem, this decision tree might actually help you. What kind of app you are building, right? If it is a stateless kind of an HTTP application, which means it can be a static site or something like that, right? Or it might have some additional components to it, even a 3-tier application. You might want to go on the left-hand side of the spectrum, okay? Then, okay, so first let's finish the right-hand side. That's the easier one, right? Happy path dikh raha hai shayad se wahan pe. Correct? If it is driven by just small events, right? I say that, in my whole application, there is probably a file upload that is happening. I only want to run this application when there is a file upload required, correct? Very simple use case. In that case, let's go for a cloud function. It is going to validate whether it's a PDF, whether it's a JPEG. Only that validation is required. Then I can go for a function kind of an app, right? Or function kind of a service. But let's go back over here. You need Kubernetes or a configurable hardware. You want to control the hardware, right? You probably want to over provision. आपके पास बहुत पैसा है. You want to bill it out to the cloud providers. You can do it. आप Kubernetes पे चलाओ, ठीक है? And you want more control, which means that probably you want to partially run some components of your application on-prem as well, right? There is Anthos for that, right? So let's not get into those complexities. But let's say you are not wanting to do a configurable hardware. You are not bothered about, again, the core component, the infrastructure. I don't know where it runs on cloud, how it runs on cloud. This is my application. मेरे को ऐसे इसको serve करना है, इसको चलाना है, ठीक है? So in that case, Cloud Run will be the most suitable option for you, correct? Now, over here also, there is one more question that comes up. Is it custom libraries, or is it something of the system libraries, or some proprietary algorithms or tools that you are using, right? If it is yes, okay, which means that you are in control of what you want to package, right? It's not a standard PHP or a JavaScript or something of that sort. In that case, right, if it is very standard, right, App Engine will also do for you, right? Even that is an alternative. But when it is something of a very customized library set, right, in that case, Cloud Run will be the most suitable option for you, right? Let's look at some of the advantages or feature sets of Cloud Run. Again, you can read through the features. I don't need to explain that. I mean, we spoke a lot about it. You look at this side of the visual as such, right? What do you see? There is two services running. Let's assume those services are basically HTTP apps, right? Simple web apps. When a request actually hits one of these services, right? Only at that instance, okay, you will see the container instance getting spin up. Whereas for request B, or rather service B, there is no container instance running, which means that it is lying in a dormant state. That application, only when someone wakes it up, okay, it is going to spin up that container, which means a lot of cost saving, a lot of infra saving, and it's very easy to kind of provision the infra for this, correct? Especially for containerized applications. So again, a lot of features. It uses Knative under the hood. You know, I mean, the Knative is itself like, I would say, open source, right? You can have your own Kubernetes YAMLs written for this, and it can be automated with your build pipelines as well. Okay, again, scalable, easy to use, don't need to explain all this, right? That's what I have been talking. The best part is highly integratable, interoperable with existing systems. So although I have mentioned cloud build, artifact registry, or secret manager, Docker, right? Even beyond the Google ecosystem, you can integrate, your own components, whether it is you're using Jenkins, whether you use a JFrog registry, whether you use a Harbor registry, you can still integrate every of these components to serve it with Cloud Run, okay? So highly integratable. Okay, who kind of are DevOps guys or infra guys over here? Yeah, a few of them over here. Okay, good. How many times have you worried about the cost part of running the infrastructure? Yeah? All the time, right? That's a nightmare, correct? I believe nowadays DevOps guys are transitioning into FinOps, right? They have to worry about, okay, if I run my service overnight, if I don't deploy it correctly, bill bahut aane wala hai, correct? So again, the best part with a service like Cloud Run is the fact that if you see the first line over here, right, which is where the CPU consumption, okay, for Cloud Run is only on bursts, right? It's only on request. If you see that, compare it with the previous one. Whereas the lower one, right, okay, when the CPU is always allocated, right, in Cloud Run you will have both options, right? Let's say आपको confident नहीं है कि whether that CPU will spin up on time or not. I don't want to have a low latency. I always want one CPU at least to be running, or one container instance to be always running. Okay? In that case, right, you can always have the CPU running, right? But okay, you can also provision it in the default manner, okay, where only on demand, right, you will have the CPU to be provisioned, and in that case you will have a better billing provision in that case, right? Moving forward. Okay, we spoke a lot about the features. Again, I mean, just compressing a lot of things together. But, okay, if let's combine this with now AI, correct? What do you need to run these kind of applications on AI or for AI, right? You'll need integration capabilities, right? To integrate with some sort of databases, some enterprise databases. So again, if you look at this visual out here, right? The first point or the first block, the big block that you are seeing, right? This could be your serving layer, right? When I say serving layer, right? This is the place or the application which is actually taking in the prompts, right? AI guys, you all will understand what is prompts, prompt engineering, prompt manipulation. In fact, if we talk about just taking one step back, right? The way in which security or the hacking industry is kind of moving, right? There is a whole big, thing moving around security of the AI, right? And you might want to read something upon that. So do refer something called OWASP Top 10 for LLMs, right? There is a lot of things around prompt injection, prompt manipulation, supply chain vulnerabilities, and so on, right? So again, coming back over here, right? AI applications, right? You need to understand what is the prompt, where it is coming from. You want to, tweak it. You want to kind of use something like LangChain in between, right? Use Cloud Run for that service, right? Very easy to scale. And in the backend, okay, probably you might be using something like an AlloyDB, Postgres, whatever you want to use, right? And you map it with your Vertex AI. Again, more of a GCP ecosystem, but the integration with your vectors or your LLMs could be anywhere else as well, right? It could be your on-prem systems or anywhere. As far as these are APIs accessible over the HTTPs and the normal ports, you can very well do that. Correct. What is the next thing that you need, right? You need a URL capability, right? Or probably a public domain capability with multi-region serving capability, right? Because you are wanting to have scale, you are wanting to have lower latency, right? Especially this is the serving layer, right? So this is where, Cloud Run as a service will have something of an internal load balancer in itself, which kind of manages this, right? In fact, a lot of customers would actually use Cloud Run for A/B testing as well, right? You use 50% of your traffic on service A, 50% on service B, right? And that can be also managed. So again, without having to worry about the infrastructure. So you can have your own domains mapped, right? In fact, I run my landing page of the blog on Cloud Run, correct? And then there is a layer which kind of talks about integrating it with the backend on Cloud SQL. Of course, that's the costly part of it, but the landing zone itself, the landing page, imagine the bill that I get with, almost like, 2,000 to 5,000 hits per month, right? Imagine the bill I might be getting. Any guesses? It's not free, or Google does not pay it. It's approximately 26 to 27 rupees per month. Okay? Probably cheaper than, any odd thing that you might think of, right? So again, you get capability to serve across regions. You can decide and choose whether you want to do a multi-region deployment or a single region, and accordingly, the load balancer will take care of it. Okay, before we go into this, right, let me show you something. We'll see an actual live demo of how Cloud Run is behaving. Okay, so you see this URL out here, okay? You'll get a chance to kind of hit this URL, okay, and try it out and see how is it scaling forward. Right now, if you see the request count, do you see any request count over here? Probably, 15 minutes back, I was just testing it out to be sure that it runs, right? And it was running, right? Right now, do you see any request over here? Or do you see any container instance that is running? In fact, if you see over here, okay, what have I set the minimum instances to be? It is 0, right? Which means no instances are currently running, right? Only when you all are going to hit that request, we'll see the container getting spin up. So why don't you go ahead and hit this request? Open this QR. It's a small app that is developed, right? Serving on Cloud Run. and it's using Vertex AI in the backend. It's like a, you can say, a very small version of Chat GPT with Gemini. You'll have opened this. Okay. Is the page loading? Most of y'all trying it out. I think what, this is 400, 500 folks. I should get that many requests. Don't worry about the bill. Right? You want to see it live in action? Let's see how it behaves. Yeah, probably some requests are coming in. Anyone not able to load the page? Yeah, a few of them. You want to try again? Try hitting it again. What I see is that the app is working fine. You see, you're seeing these spikes. Yeah. The app is up. I mean, don't worry about the UI. I'm not a UI guy. I just wanted it to serve. Yeah, probably a lot of you are seeing that request coming in. It might just take a little bit of more while. And you are seeing container instances getting, getting shot up. I'm seeing too many requests, right? Probably I have not configured a load balancer in this case, right? And I just wanted to hit that, URL as much as possible, right? So you all were kind of actually probably breaching some of the thresholds, right? Again, not tested in this large environment, right? But yes, you can still, so if you see it over here, I can still kind of see the URL up and running, right? And it is meeting that kind of a scale. Yeah, if you see the page is now loading, right? And probably if we kind of re-hit this.
That's what say that. Back.
Yeah. It's a bit of a high latency right now. But yes, you're starting to see, more instances getting spin up over here, right? And that request is going through. Right now, if this is something that you want to try by your own, right? There are 3 demos, right, available for your own consumption, right? The first one is the same app which you all saw right now, right? You can deploy it for yourself. The second one, there is an interesting function called, interesting demo called Gemini function calling, right? If you want to just consume certain Gemini functions for yourself, right? That is the second lab. And the third one, right? Like, look, I mean, Cloud Run as such, right? It works, in 2 ways, right? One is like a job, one is like a service. So when you say service, right? It's basically a web app that you are trying to serve. But when you want to do batch processing, right? When you want to do a lot of image, video processing, right? You can use it as a job. It will run in the background, more like an asynchronous, service. Once that job is complete, it will hit it back to the URL saying that, hey, this is complete, right? You can take the answer or, do the next processing. So again, that's also event based. So you can try out all these 3 labs, right? For yourself. You can take a picture. All of these QRs are basically, code labs that you can try it out on your own. Okay. You might need a cloud account to deploy it. But if not, right, you can still understand how Gemini works or how Gemini is integrated with Cloud Run, right? Captured this? Yeah? Okay. Now, maybe let's take a quick walkthrough, okay, of how will Cloud Run, okay, serve if you have to design an RAG application. Anyone doing RAG over here? RAG apps, right? Yeah, a few folks out here, correct? So if you understand, right, if a typical architecture, right, a standard architecture that might look for an RAG application is something what you see on the screen. An ingestion layer, okay, a training or a quality layer, and a serving layer, right? And probably it will have a data lake or databases in between to kind of aggregate everything, do the processing part, and store it, right? This is what it looks under the hood, right? Again, don't get overwhelmed by what are the components or how will it look like. But if you see the layers out here, right? Every layer, right? Whether it is the ingestion, the file processing part, the evaluation part, okay, or even the serving part. So in the serving, you don't see Cloud Run anywhere. Why? Because it's an optional choice, right? You might want to use it, you might not want to use it, right? And the front end is actually the Cloud Run piece of it, right? Where the evaluator is directly connected, right? Because it's wanting to kind of ingest those prompts, process it, and then take it forward, right? Making sense? At least where you can use Cloud Run across an RAG or across an LLM application, right? And of course, with all the integrations that you can see, right? The file processor is directly integrated to the 𝗟𝗃 AI embeddings for text, okay? If you see the backend over here, more of your foundational LLM is over here. And of course, this whole underlying layer, right? You need to have monitoring, observability capabilities, all that comes across, right? So this is where probably you can use Cloud Run in depth. Maybe a few more slides if you want to understand this in depth, right? Again, if you see the database layer, right? If you see the previous few examples which I was showing, right? You can integrate this with AlloyDB, depending on your use cases. Whether you want to use Postgres, Alloy, or any such databases, right? And over there also, if you see, these are running as jobs, right? Why? Because I want to do a asynchronous processing of my data sets, okay, and then take it back to the quality evaluation system. So this is where you can probably use that. Same applies for front end. We actually discussed that. We'll skip through. And over here as well, right? The output that was coming from the ingestion system, right? It goes back, okay, from the database to the evaluation systems. Over here also, if you see, it is used as a job. Why? Because I want to do an async processing. Probably, some evaluation trigger is there, okay? I want to kind of do that and check whether, my prompts, my responses, I want to understand a feedback mechanism. There has to be some evaluation scores. I want to check, what does the temperature look like and so on, right? So this is where, I can use it as a job, okay? With that, right, I think that's the end of the session. Thank you so much, everyone, okay? Any questions, feel free to, yeah, thank you. Any questions, feel free to ask. If we have probably 3 or 5 minutes, you can take up some questions, or else those are my credentials. You can connect with me on LinkedIn, Twitter, usually responsive on these platforms. Or of course, if you want to know more about what I do, there's a platform called Prisma Cloud, which actually does a lot of cloud security, what Sir explained a while back, right? So that's all from my side. Thank you so much, everyone.
Thank you, Dharmesh. Thank you very much. It was an insightful session, right? So can I have a huge round of applause for Dharmesh, please? Come on.